Hi, this video is on Chapter 1, Section 1, whole numbers, and we're working in this video on rounding. So I did copy a table from our PowerPoint notes that we've been working with, but before I jump into the way our textbook author presents rounding, I wanted to show you a way I think about it and how some of my students have found that this is a little simpler way of thinking about it. So I'm just going to go ahead and give you some examples and we'll take it from there and then go back and check in on what your textbook author is sharing with you as well. Okay, so let's look at this number 173. And suppose I want to round this to the nearest 10. So we want to round to the nearest 10. So just so we understand what that means, I'm going to draw a little number line and show you what this is. So maybe we have this number line here. And it goes 150, 160, 170, 180, 190, 200. And I want to find 173. So I kind of just took the interval from 170 to 180 and I put little tick marks for each of the numbers, each of the whole numbers between 170 and 180. And 173 is right here. So I'll make a big circle. So rounding to the nearest 10 means figuring out whether this number is closer to 170 or to 180, okay? And so when we look at the number line, maybe we see that 173 is closer to 170. But I'd like to be able to also be able to round without going through drawing a number line and just by looking at the digits, okay? So we have a rule in rounding, and the rule says that if I'm going to go ahead and take 173. We'll go through that rule in a minute. So we want to round 173 to the nearest 10. So when I round, I take the number that's in the tens place. Remember the place value table. And in this case, that number is the 7. Now I'm going to build a wall, the rounding wall. And I'm going to stand right here and look over the wall. And I look at that digit. So all I see is that digit. And if that digit, so the rule is, if that digit is 0, 1, 2, 3, or 4, I replace it with a 0. And the rounded number then would be 170. If the digit is 5, 6, 7, 8, or 9, I increase my 7 to an 8 and then replace the digit with a 0. And so the 170 would go up to 180. But when we go ahead and we use this rule, 173 rounded to the nearest 10, I find the tens place, I look over the wall and I see it's a 3, then I just have to replace the 3 with the 0. I don't increase the digit with the 2 lines underneath it. So let me give you a few more And we're just gonna build this rounding wall. We're gonna peek over the wall. If the digit is 0 to 4, we don't increase that number by 1. If it is, if this digit is bigger, 5, 6, 7, 8, or 9, then we bring it up. So let's go ahead and take another number. 1, 7, 3, and 6. So 1,736. And I want to round that to the nearest 1,000. So my rule is I go to the digit that's in the thousands place and put 2 lines under it so I know what I'm thinking about. I'm going to build my rounding wall and peek over the wall. In this case, the digit that I see is a 7, so it means I need to increase the 1 to a 2. So this number, rounded to the nearest 1,000, is 2, and everything else turns into a 0, okay? So 1,736 rounded to the nearest 1,000 is 2,000. It was either going to be 1,000 or 2,000, but because this digit here was in that second chunk, 5 to 9, then we rounded up. Okay, let's do another one. Okay, so there's a big number, 216,749, and I want to round that to the nearest, round to the nearest 100. So I go and I find the number in the hundreds place and I put 2 lines underneath it. I build myself a rounding bar and I peek over the wall. It's a 4. When I'm in a 4, I just replace everything to the right of the wall with a 0, and I don't increase the 7. So this number, rounded to the nearest 100, is 216. 7 stays where it is, and everything to the right of the wall turns into a 0. So this number, rounded to the nearest 100, is 216,700. All right, let's do a couple more, and then we'll come to this rule that your textbook author has to offer. All right, well, how about we do one more here? So 199, 9, 9, and 9. And I want to round this to the nearest 100,000. I'm just going to separate these problems because in a minute I want to refer back to the textbook author's procedure, okay, and make sure that everything makes sense. Okay, so I want to round to the nearest 100,000. Okay. So our procedure is to come over to the number and put 2 lines underneath the digit that's in the 100,000 place. Draw a rounding bar, a rounding wall there, and peek over the wall. So that 9 is in the bigger chunk. So it means that we have to increase the 1 to a 2, and everything to the right of the bar turns into a 0. So this number, rounded to the nearest 100,000, is 200,000. Okay. All right. Well, I have one more that I want to do. It's a little tricky, so I want to make sure we go over some of the tricky stuff. Okay. And we're going to take that same number. $199,999, and I want to round it to the nearest 10. Okay, so I'm going to put 2 lines, two dashes underneath the digit in the tens place. I'm going to make a nice bar here for rounding. I'm going to peek over the bar. When I peek over the bar, I see a 9. So that means I have to increase this digit with the 2 dashes underneath it. I'm going to increase it by 1. Okay, but when I do that, the 9 is going to go to a 0. And it's going to go up, so it's going to go from a 9 to a 10, but it can't go to a 10, so it makes this guy go up to 1. And the same thing is going to happen all the way up. So I have to increase the 9 to a 10, which means I need to increase this 9 to a 10. So everything moves up, and this number rounded to the nearest 10 is also going to be 200,000. Okay. Because there's nowhere else when I go to round it up, everything bumps up by 1, and that is fine. That's what happens. So this number to the nearest 10 is also 200,000. Now, I just want to go through this table that your textbook author offers us, and it says when rounding to the nearest 10, this means the rounded number has to end in at least 10. So when we came over here and we rounded 173 to the nearest 10, that number rounded to 180. Okay, so we looked over the rounding bar, we saw a 3, so this digit did not increase. Okay, so and the number has at least 10. Okay, rounded to the nearest 1,000. This number rounded to 2,000, so if I want to round something to the nearest 1,000, then I am supposed to have at least 3 zeros, and I do. And this guy here, rounded to the nearest 100, has to have at least 2 zeros, and it does. And this one, 199,999, rounded to the nearest 1,000, has to have, rounded to the nearest 100,000, excuse me, that's going to have 5 zeros, right? So that was so many down there, I didn't put it on the chart. But it does, it has 5 zeros, 200,000. But let's come back here and look at this one. That same number, 199,999, rounded to the nearest 10, is supposed to have at least 10. Does it have at least 10? It does. As a matter of fact, it has 5 zeros, and 5 zeros is at least 10. Okay. All right, let's see if there's any more interesting tidbits from the textbook author. I think we can just read one more problem, and the Robinsons, it's sort of good to start to read the word problems because, you know, it's always interesting to bring the words and the numbers together. Okay, so the Robinsons are having new windows installed, and the price is $12,870. How much to the nearest $1,000? Okay, so find the digit that's in the thousands place. It's the 2. Draw your rounding bar and peek over. And because this is an 8, it's in that 5 through 9 group, it means that the 2 is gonna go up to a 3, and everything to the right of the rounding bar goes to 0. So we're gonna write that as rounded to the nearest 1,000. That's what we're looking for. And so this number goes to 13,000. Okay, so that's it for rounding. I'll see you next time.